if you look back into the history of reflective waveguides, it's out there since years. And there was a kind of, I would call it a historical perception of the community with respect to reflective waveguides, which basically says it's a great concept, but. And these buts had been, let's say, very seriously discussed in the industry. Number one, there was no 2D pupil expansion approach shown. And secondly, up to a couple of years ago, nobody has shown manufacturability of reflective waveguides. So what to do? From a SCHOTT perspective, obviously here again, coming to the pioneering spirit of our founder, we said, okay, if manufacturability is an issue, let's have a look at it. And now SCHOTT here has a very unique setup in the industry, because we may be the only company that has in-house glass, wafer processing, optical coatings in very demanding aspects, and we do have manufacturing of optical components in-house, and we have all the quality and application technology. So this is probably in the entire industry landscape a very unique setup, which said, okay, let's give it a try, because if this setup has any value, then the quality can be delivered because it's intrinsically, we control it. We can be faster and more flexible because everything is in-house. And also not to forget about costs. Once you have all of these process steps in-house, you have not this traditional pile-up of margins that every company has to earn its money by margin. We can, let's say, basically work here by internal transfer pricing and then take the margin at the end. So 3 reasons why we thought from SCHOTT side it's a good reason to work on reflective waveguides. And so here, I would say 1 year ago, roughly, we went public with our cooperation with Lumus. Lumus is, I would say, the leader in reflective waveguides. They are more since 20 years in business. And one of the things that was, let's say, behind this cooperation was that Lumus was working with SCHOTT supporting for manufacturability on a new architecture, which delivered the 2D pupil expansion. You recall that this was one of the buts of the historic perception. Now with the Maximus architecture, there is 2D pupil expansion, which ultimately there is a device out which demonstrates 50-degree field of view. Reflective waveguides are known to be significantly better in efficiency than just by, let's say, physics, than, for example, surface relief gratings. And also image quality was always in the mind of being super good. Yeah. So that was one part of the cooperation that we provided. Lumus provided an architecture for 2D pupil expansion, branded under Maximus. And this was already co-developed with SCHOTT from a manufacturing standpoint. So we are happy that we have, let's say, in parallel since 2.5 years, we have built up a processing line, which is in charge of manufacturing reflective waveguides along exactly this value chain as you see it here: glass, wafer, coating, and then the final assembly. And that's, let's say, from our perspective, is something where it is a very attractive addition to the waveguide landscape. We do have our pilot line up and running in Malaysia, which is designed for the current, let's say, level of the industry of roughly 1,000 waveguides per month we can manufacture there. Of course, it's a pilot line, but there is a real process and a real product. And this is an addition to the waveguide portfolio of SCHOTT.